Yeah, so towards the end of last lecture, I was talking to you about how in an SQL query we will be making use of what are called subqueries or nested queries. Okay. Basically, this feature of having nested queries will allow us to kind of break down the computation, break down the specification into logical units, and then specify them using independent queries, and then make use of the results of a subquery in the outer query. So, in while doing that, we needed operators for comparing or making use of this result of the subquery. So, we have talked about this in the last class, that if so these are the kind of operators that we use for comparing the results of making use of the results of a subquery. If S is a subquery, then we can put it in this kind of an expression V operator in S, and we have seen what are all the various operators that are allowed, and what is the meanings of all these operators. So, in is a short form for equal to any, and not in is equivalent to equivalent to not equal to all, and in general we can also have the V, which is generated, which is kind of produced by the main query the main query. It is possible that this particular V is also a tuple, in which case the S is in generating compatible tuples. Okay. So, V is normally a single attribute, but while using this in and not in, it can be a tuple of attributes, in which case the same kind of semantics will apply. So, basically if this is a tuple, then if you are using any, then we are basically checking is there exactly equal tuple in the result produced by S. Similarly for not equal to. Okay. So, moving on, in this lecture I want to focus on a few more features of SQL, the query part of SQL. There is this notion called correlated or uncorrelated nested queries. Okay. So, if the nested query result is independent of the current tuple being examined in the outer query. So, this requires some explanation. What do you mean by current tuple being examined in the outer query? Recall that the meaning of a basic block is that at any point of time we are considering a particular combination of tuples of relations that are mentioned in the from clause, right. So, that is the current tuple under consideration. Okay. So, if the nested query the result of the nested query is independent, it does not care about the current tuple being examined in the outer query, then such a query is what is called an uncorrelated query. Whereas, if this is not the case, we call such a nested query as a correlated query, because its result is in some sense correlated with the current tuple being considered in the main query. Okay. So, I will give examples of these things, and then you can try to understand. If it is an uncorrelated query, then the advantage we have is that the nested query can be computed only once, and then its results can be made use of in the main query. Okay. So, whereas if it is a correlated nested query, then the nested query kind of needs to be recomputed for each of the tuple combinations. You can also call it a row, being examined in the outer query. Okay. So, that is the one of the so this difference is of great value when we are actually looking at the efficiency of running of the queries. So, if the nested, if you detect that the nested query is an uncorrelated query, then we can actually keep the computation, run it, and then take its result, store it somewhere, and make reuse that result. Okay, so let us now start looking at examples of this. Okay, so I want to keep this. I will keep the examples simple, just to kind of illustrate the main point that we are looking at. So, get the roll number and name of students whose gender is same as their advisor's gender. You may wonder why do you want this information, but just for illustration purpose. Okay. So, basically I am now looking at whether, so you can see that as I am kind of looking at various student tuples, I must then make use of the value of the sex attribute and then check with the advisor's attributes appropriately. So, that is where the correlation comes into picture. So, this can be specified easily like this: select this roll number name from the student. Here you can see that we are using s dot advisor here. So, this subquery, which is checking whether the gender of the professor is the same as the gender of the student whom he is advising, he or she is advising, okay, is making use of the table alias that is there in the outer query. That is the only way you can check that condition, because so this also brings into the focus that these table aliases that we introduce in the from clause are accessible to the subqueries. Okay. They are accessible and they can be made use of in the subqueries. So, in the subquery now I am doing select f dot x, f dot sex from professor f, where f dot employee id is the s dot advisor. That means this particular professor is the advisor for the current student under consideration. There is some current student under consideration. Yeah. Yeah. So, you are wondering whether is there a your question is if this nested query, what does it generate? It generates one tuple. So, in which case is equal to all is required or not, right. So, it does not matter, right. Even if you put equal to all or equal to any, it would be the same, actually the effect will be the same here. So, you could actually replace it by any here, or you could also just use in, right. So, so this is basically producing the one value, and then we are checking whether this particular thing. The main point I am trying to illustrate here is that this subquery is correlated because its value or it whatever it produces depends on the current student under consideration. Okay. So, compare this with the query that we had, where we said get hold of all students whose advisors are female professors, and then we used a subquery to figure out who are all the female professors, and then checking whether the student, the advisors advisor of the student, the employee ID is present in the employee IDs of the female professors. Okay. So, that subquery can be kind of independently run without without bothering about what is the current student I am considering, because that subquery was basically just generating the employee IDs of all female professors in the institute. So, that is an example of a uncorrelated query, whereas this one is formulated as though, I mean formulated such and in this kind of formulation, this subquery result will depend on the current tuple being considered for student, and so it is a correlated query, example of a correlated query. Okay. So, that is the difference between correlated, and we will see some more examples of these correlated queries as we go along. So, now let me take you to a very interesting operator called the exists operator. So, in SQL there exists an operator called exists, and so what is this operator? It basically allows you to check whether a particular subquery is producing non-empty results or producing empty results. Okay. So, that is all it does, but it is very useful, and it in some sense plays the role of an existential quantification in SQL. Okay. So, the exists operator is expressed like this: exists S, where S is a subquery, S is a query, but usually it has to be used inside. So, this now becomes a new predicate thing. So, you can use it in a where clause of a query, and so S becomes a subquery of that particular query. Okay. So, this exists S is true if S has at least one tuple, and is false if S contains no tuples. So, it is very simple, and we will start using it now. Get the employee ID names of professors who advise at least one women student. So, now we will we will try to get a subquery of all the advisees of this women advisees of this current professor under consideration, and then check whether that particular set is empty or not. That is the idea of trying to use an exists operator. So, select f dot employee ID, f dot name from professor F, and now here comes the subquery. What is this subquery doing? It is go through this: select s dot roll number from student S, where the student's advisor is the current professor under consideration, f dot employee ID, and the student is a woman. Okay. So, essentially what it is doing, it is producing the set of women advisees, roll numbers of women advisees of the current professor, and then we are checking whether is this set empty or not. If this set is empty, then this particular employee ID is not advising at least one women student, and so should not be produced in the output. And so, if this thing is null set, then exists that null set would be false, and so for that professor this predicate will be false, and you will not be producing that professor in the output. And if at least there is at least one member here in this as a result in the result of this subquery, then exists for this S is true, and so that professor will be listed as the professor who is advising at least one woman student. Well, see, in all these examples, remember one thing, that I am using them to illustrate certain of these features or operators that are there in SQL. You can also express the same very queries in other ways. Okay. Every query can actually be expressed in many ways, and I am choosing the way of expressing using the features that I am introducing, and it is not, it should not be assumed that this is the only way to express the query. So, you can express the same query in multiple ways, remember that. Well, okay, then let us move on. This is happens to be another correlated query, because its subquery, I mean the result of the subquery will depend on the current professor under consideration. Unfortunately, while this exists is something like an existential quantifier, SQL does not have an operator for universal quantification. It is really unfortunate that we do not have a universal quantification operation in SQL. There are other query languages like object query language and XQuery and a little bit query languages for more advanced data models, for in which at the design stage itself they have kind of incorporated the universal quantification, because it is really useful quantification. So, as a result of this, we will have while dealing with these queries that do involve universal quantification, we will be kind of forced to convert that into existential quantification and then use exists operator to kind of check those the conditions that we are looking for. So, let me illustrate that point. Before we go further, here is a not exists operator. So, if exists operator of course exists, then not exists will not be not existing, right, it will be existing. Play of words. Anyway, not exists operator exists. Obtain the department ID and name of departments that do not offer any 4 credit course. So, you can basically do this query by asking whether the department is or producing the set of departments that are offering 4 credit courses, and then checking whether, let me show you the query. Department ID, name of the departments that do not offer any 4 credit courses. So, here is a subquery. What it does is produce the 4 credit courses that are being offered by the department under consideration. Okay, how does it do it? Select course ID from course C, where C dot department number equals D dot department ID. This will kind of ensure that the course is being offered by the current department under consideration, and further check that the credits is 4. So, this will produce the set of courses that are of 4 credits and are offered by the department under consideration. What is the department under consideration? This is this D. So, we will consider all possible values for D, right. So, for each of these D's we are kind of computing what is the set of 4 credit courses offered by that particular department. If that is so, if this is a set which is a non-empty set, then the department does not qualify for us, because we are asking for the departments that do not offer any 4 credit courses. So, that is why we put a not here and then use not exists to get this condition that they do not offer any 4 credit course. Okay, this also happens to be a correlated subquery. Okay, so both exists and not exists are very useful operators, and most of them queries involving existentially quantified predicates can be kind of easily specified using this exists operator. But queries with universally quantified predicates can only be specified after we actually convert that predicate into something which uses existential quantifiers. So, let me illustrate that. This is a very interesting part of the the queries. We have looked at this query earlier also when we were talking about tuple relational calculus. You have not looked at the tuple relational calculus slides yet, looks like. So, go and look at them. We have this is the example I was discussing when the power went off, right. So, I had to kind of determine the students who are enrolled for every course taught by Professor Ramanujam and assume that Professor Ramanujam teaches at least one course. Okay. Oh, why do you think that it involves a universal quantifier? That is because we are specifying that these students whom we are interested in are enrolled for every course taught by Professor Ramanujam. Okay. So, one way of handling this, I mean actually the way to handle this is since SQL does not have the universal quantifier, we will rewrite this into something like this. So, determine the students is kind of equivalent, right. Determine the students who are such that there does not exist a course taught by Professor Ramanujam which is not enrolled by the student. Okay. So, which will semantically mean the same thing as the student is enrolled for all courses taught by Professor Ramanujam. It is not the case that there does not exist. So let me let me read it again. Determine the students who are such that so there does not exist any course that is taught by Professor Ramanujam which this particular student has not enrolled into. Okay. So, this is you can see that this is equivalent to the condition that we are asked to check in this query. And now, since it uses exists, we can express this in SQL. Before I move on to SQL, let me show you how we did this in tuple relational calculus. Okay. Just recall that slide here. The same query in TRC, we did it like this. I wanted to go through this, just I explained this thing earlier. So, essentially what we are doing here is use this implication and a universal quantifier and express this particular condition that we are looking for is that for all courses taught by Professor Ramanujam, the student under consideration has done that. Okay. So, this translation is somewhat easier and direct translation of the condition that. So, every course taught by Professor Ramanujam has been done by. So, the way we express this, if the antecedent of this implication checks if this is the course that is being taught by Ramanujam and the consequent checks whether the student has enrolled for it. Okay. And this is universally quantified for all courses. For all courses, we are checking that if the course is taught by Ramanujam, then the student has enrolled in that. So, this you can see is a more direct way of translating the the query. Fortunately, we could do that because we have universal quantification at our hand, and of course, implication also is present, and so we could do that. Now, take it as an exercise and then write down the where clause part of this in predicate logic, okay, and put two negation symbols in front of it. If you put two negation symbols in front of it, it is logically equivalent to the same thing, right, that expression, and then push one of the logical push one of the negations inside the bracket, then see that you will get an equivalent expression that uses only existential quantifiers, and that you can express using. Okay, so let me now show you how we can deal with this in SQL. Determine the students who are enrolled for every course that is taught by Professor Ramanujam. So, that is the okay. So, pass this slowly. There is double negation, so it will be a little bit confusing. So, but that is inevitable. So, what we are the logic we are encoding here in the condition is that there does not exist any course that is taught by Professor Ramanujam which is not enrolled by the student under consideration. Okay. So, there is a select roll number name from student S, and we are so something does not exist. What is that? A course taught by Professor Ramanujam which is such that the student is not enrolled for it. Such a course does not exist. Okay. So, that is easy to express. So, select T dot star, okay, but dot star is basically saying that get me all attributes. From teaching T, Professor P, you recall that this teaching information, who is teaching what, is available in the teaching relation, and so we get the appropriate combination of the teaching tuple and the professor tuple by doing the employee ID is same in both the tuples. We ensure that, and the name of the professor is Ramanujam. So, this will kind of fix the combination of the teaching and professor tuples, appropriate combination of teaching and professor tuples, such that the course is being taught by Professor Ramanujam. And then we are checking that in the enrollment tuples, E dot course ID is same as T dot course ID, that is, this is the course that is being taught by Professor Ramanujam, and the student has enrolled for it. Okay, there is a not exists here, remember that. So, yeah, so if if such an enrollment tuple where the combination of the student roll number, this S dot roll number is the roll number of this particular student under consideration. Remember that there is no other S anywhere here. So, this is the scope of this is the entire subquery, and it is coming here. Okay. Remember again, what is it that we are checking? We are checking that. So, under the subquery, what we should get? A course taught by Ramanujam which is not being enrolled, which is not enrolled by the student. Such a set should not be, there does not exist such a course. That is the job of this outer not exists. Okay. So, the subquery is checking for the set of all courses taught by Ramanujam which are not enrolled by the student. That is exactly what we are doing here. So, we are checking that enrollment tuple corresponding to the student under consideration with the corresponding course ID does not exist. Okay, any questions here? Because this is something which we have to pause and ensure that we have understood this what I would advise you to do is to kind of take some sample values of courses taught by Professor Ramanujam, some say 2-3 of them, and then run through this using a paper pencil simulation, and then figure out that indeed it is. So you can take the combinations of student doing some subset of those courses and student doing all of the courses, then you will figure out that this indeed will ensure that the student is actually enrolled for every course that is taught by Professor Ramanujam. Now let me show you a similar kind of a query which again involves universal quantification. Determine the students who have enrolled who have obtained either S or A grade in all the prerequisite courses of the course, some number 7890, and it is known that 7890 has at least one prerequisite. Again this also involves checking some kind of condition for all the prerequisites of a particular course. I will leave this as an exercise for you to figure out that the same kind of a translation into existential quantifications is required here, and then you can express it like this. Okay. So you can we are asserting that there does not exist any prerequisite of CS 7890 such that the student under consideration has not got either S or A grade in such a course. Okay. So that is what this part of the query is doing. This part of the query is checking, ensuring that the course under consideration P is a prerequisite of the CS 7890, and this part of the query is checking whether the student has got S or A and there is a not exists here. So the way you can convince yourself about this is to assume that say the course has some 3 prerequisites C1, C2, C3, and then check assume that the student some student has done 2 of them, has got S or A in 2 of them, and then what happens to that student. You can run through this and then ensure and then you will be able to figure out that that student will not qualify in this. So the point I am trying to illustrate is basically that for those kind of queries that do involve checking conditions that kind of involve the universal quantifier, you rewrite the condition in essentially using double negation and then use the exists operator to express that composite condition. And I have given 2 of these queries so that you can get this point across, and I urge you to kind of practice more such queries. Okay. So you can also study these queries and then come up with any questions that you may have in the next class so that we can clarify them again. But it is kind of important to understand how to express these kind of conditions in SQL. Of course, my advice is for you to try and express this in tuple relational calculus first, so that you are kind of ready with the the condition that you want to express, and then convert that into SQL. Okay. So, that is about this aspect, the exists operator and the way it helps us in expressing both universal quantification, I mean expressing conditions that are that involve existential as well as universal quantifiers. So, moving on, the where clause can sometimes be missing in the SQL query. If that is the case, essentially you will take it as a condition that is always true. Okay. So, remember in the basic in the interpretation of the basic block of SQL, the where is a kind of a filter for all those combinations where in which the where condition is true, you are going to use that to produce the result. So, if the where clause is missing, then what we will do is assume that all combinations satisfy the condition. So, it is a kind of a always true kind of condition. So, essentially no filtering is done on the cross product of the from clause relations. So, a simple example could be that get names and contact phone numbers of all departments. So, select name from department, you do not have to put any condition here. The next set of operators actually have to do with this union, intersection and difference operations. So, these operators can be made use of in SQL as well. Essentially what we need here is that the two operands for these have to be union compatible. Recall this notion of union compatibility, we have used it in relational algebra. So, essentially the two queries, two subqueries can be the results of two subqueries can be unioned, or you can use them for intersect and things like that, but then both the subqueries should produce results that are union compatible. Not only that, here we make even stronger assumption here that they should have the same attribute names in the same order, both the operands, same attribute names and in the same order. This is one aspect. Then the other aspect is that the results of these operators are sets actually. This is another, it may be slightly confusing, but these are sets, that means duplicates will not be there. So, if some tuple exists in A and also exists in B, then A union B will have only one copy of that tuple, it will not have duplicate copies. So, it produces sets. Let me show you, let me quickly show you some 2-3 just simple examples for illustrating this, and then we will close the lecture. Obtain the roll numbers of students who are currently enrolled for either this course or that course. So, obviously you can do it by just putting this condition in the where clause, but I am kind of using it to illustrate how to use union. So, I will current semester or 2019 and the select roll number from the enrollment where the course ID is this, and here is the keyword union, and the other thing is exactly the same, but this course is replaced by 2320. Of course, it is kind of equivalent to you can put this or here in the condition itself. So, the same example I have used in order to illustrate intersect and also the difference. So, I will skip this. The except, so the keyword used for difference is except. So, this except this, that means the so here is the query, obtain the roll numbers of students who are currently not enrolled for 2300 course. So, you can get all students that are currently enrolled and then subtract the course students who are currently enrolled for 2300. So, except yes. Okay. So, with that we will close for today. I will continue this SQL discussion on SQL using and by bringing in what are called aggregation operators in the next class. This is going to be very interesting because they will be used for data analysis and other things. So, we will see how we can express aggregations. But remember one thing, please keep practicing this stuff as we talk and look at more examples and express. You already have some set of queries with you and you can take queries from exercises and express them and then clarify doubts on SQL. Okay. Thank you.